and to wrap up these integral chunks. So now imagine in number 5, there's no graph. So it's just like the one up above, like for 3 and 4, you have a picture. But instead of the graph with the areas you have to find yourself, they're handed to you. They're right here. So 4, -3, and 8 are respective little chunks of the graph like we had above. So saving you the picture, and then we're going to mess with them again. So 5 to 1, doesn't it seem out of order? So what happens is 5 to 1 is the same thing as 1 to 5, but if you flip those around, you're going to put a negative in front of it. And you go up here and say, oh my goodness, I know what that is. I've seen that before. -3 is the integral from 1 to 5 of f of x. I got that, but I have a negative in front of it, so this is going to be a negative of -5, or -3, sorry. So it's +3. Okay, so it's that negative when you turn the bounds around. The next one is a compilation, so if you go from -2 to 5, so I'm going to go up here and get rid of my little highlight again. So check this out. If you go from -2 to 5, none of these 3 go from -2 to 5. They're both little shorter chunks, but you can go from -2 to 1, and that's an area of 8, and then add to it 1 to 5, which is the area of -3. So you can make it up of 2 integrals from -2 to 1. F of x, I got that. That's just 8. You can add to it 1 to 5. And that integral is -3. So you just actually put the numbers in for them. So it's 8 plus -3, and you get 5. So this one is equal to 5. And you get this, instead of a picture, you're just doing it kind of like you can picture one in your mind, but it's the values is all you've got. Okay, the next one is all kinds of fun stuff. All the properties are starting to meld together. And so -2 to 1, that's good. That's in order. Hey, look right above that. That's the bounds are good. But what you want to notice, there's more than one integral, or more than one. There's a plus sign in the middle, so you're adding 2 things together. You can split it up, and it can be a nice way to look at it. It's easier to comprehend what you're doing, so you can integrate the first. And then remember the 2, that constant you can pull out front whenever you're integrating or deriving, and you can do -2 to 1. So it's another integral with the same bounds. So whenever you do this, you can break it up and take an integral of each added or subtracted term, but they all have the same bounds. So if it's -2 to 1 on the whole thing, each individual one has to be -2 to 1. Then g of x goes here, and dx. And by the way, f of x is the first one. I forgot to tell you that the letters change, so f and g. And I think I goofed that up actually on the last one. I did. My goodness, you probably saw that and were making fun of me, so good for you. I actually grabbed the wrong function. So I added the f and the g one when I was just doing f. So let's go back. That's actually kind of a happy error we can learn something from. No reason to undo it. I need to redo that one. I should have been using, instead of this, and I knew I was going to make that when I was thinking through this, is like, oh, you're totally going to highlight the wrong one. And I did. But it has to be, if you're going to do the integral of f of x, you can only break it up into pieces of integrals of the f of x. So instead of this 3 that I put there, let's just make the error obvious and go, wrong one. It was supposed to be 4, right? Because that's the f function. I wasn't doing a g function. And 8 plus 4, that's 12. So this is 12. So I'll go ahead and delete this all together. Whole hog. Redraw. Does that sound better? You probably saw that. We're squirming in your seat. But now you can save sending them that email. Even though if you see errors and I don't mention them, send them in an email. Now we're going to go back to the next one. It is f and it is g, and it's supposed to be that way. So I'm going to read more carefully this time. So -2 to 1 under f of x is 4. So there we go. And then 2 times whatever the integral -2 to 1 of g of x is, which is 8. So it just breaks it up into chunks. You only know the integral of f and g on respective intervals, and we know that you got to put any constants, pull them out front. Okay, so we have 16 plus 4, that's 20. Okay, so this is 20. On we go. The next one, 0 to 1 of f of x. Now, I don't see that on mine. You notice that's missing. But 0 to 1 can also be the difference between things of f of x. So sometimes you can think of other ways to go about it. So if negative 2 to 1, and then I've got 1 to 5, and maybe there's like a way to anticipate what that one might be. So I'm going to leave this one open for just a second. How can you find 0 to 1? I'm actually going to put a little faux graph that goes with this. There might be, yeah, I like this. I wrote one before that might be a helpful hint. If I can find out where I put it, doesn't matter. So I think one's a negative 2. 1, 2, 3, 4, 5. We stop at 5, right? And it was negative 2 to 1 was 4. And then 1 to 5 was negative 3. Got it. Something like that. And I think that's it. So if I think of this, if I cover them up inside here, I'm saying that from negative 2 to 1, that would be like an area of 4. I'm just kind of putting a picture out because I like an idea of it. And then if I go from 1 till, is it 5? Then we'll call this area right here is negative 3. But the question is, hey, what's from 0 to 1? What's going on in there? How can we figure that out? And 0 to 1, the hard thing about that is we don't know how much information, we don't have any information to kind of how big that is, what portion of it is it, because there's a lot of ways I could have made the other area 4. So I'm going to draw some other alternatives here where this, I could have had an area 4 and it could look different. I could remorph it like this. That could have an area 4 from there to there. I could have a large chunk of it above that's like maybe 6 and then just a little bit below. Remember, integrals do net. That could have an area, a net area of 4 in that region. So what happens in that 0 to 1 region is really open-ended. There's nothing that defines it. So we cannot be determined with the information I have. Because there's too many ways to come up with the net of 4 from negative 2 to 1. I could rearrange that a lot of different ways. What's going on from 0 to 1 has never been specified in any part of this. Okay, so just sometimes you can't handle it. Just make sure it's in the bounds of things that you are defining in your function. So that picture was, I don't know if helpful or not. Oh, E, that's backward. That's totally turned around. So what we're going to do is negative 2 to 1. You got to go low to upper, factor out. When I do that, remember that makes a negative. So let's go one thing at a time. And then, ooh, that times 3, I can bring it out front. So what I'm doing is rewriting these as an integral I do know how to find, because we obviously just found out the last time if it's not one I know the area for, I'm stuck. But now I've got an area that I know. Negative 2 to 1 under f of x is 4. So I know I've got negative 3 times 4. And that's negative 12. Cool. And then the last one, we'll knock it out. Looks complicated. Oh man, f minus g, all this. Doesn't matter. It's from 5 to 5. It's always going to be 0. Cool. That's a good start to give you one of those properties of definite integrals. Good luck. Happy Drake Relays weekend.